This will be for the con exercise, derivative as a limit. All right, so for this exercise, the derivative of a function f at the point where x equals t is defined by the following two equivalent limit expressions. So each of these derivative definitions are possibilities, just one of these two. And these are both actually slope equations, which I can prove to you. So imagine if you had 2 points, x comma f of x, these are the xy coordinates, and t comma f of t. Recall that the slope is basically the change in y divided by the change in x. So in the numerator, it would just be y2 minus y1, and the denominator, it would just be x2 minus x1. And to subtract the y's, you would just do f of x minus f of t, and that's what we have in the numerator. To subtract the x's, you would just do x minus t, and that's what we have in the denominator. The idea here, as the limit of x approaches t, what we're trying to do is get x and t close together. This way, the difference or subtraction between x and t is minimized. We want these 2 points to get closer and closer together. Okay, so this is why we have x approaches t, and I'll show you why on the graph. All right, so here's a secant line right here. See, it hits the graph, the curve at 2 different points. If you had a point on this graph and you wanted to find the slope at that point, you can use the secant line to estimate the slope at that point, because the secant line will give you the average slope between these 2 points. But if you could take the secant line and make it smaller and smaller, okay, and have it zoom in on this point here. I didn't draw a proper segment there, but the idea is to have the secant line get smaller and smaller until it approaches this point. Okay, that's why we said in the formula for the limit as x approaches t. Okay, right here, we want this to get smaller and smaller. We want the points to get closer and closer together. All right, and this way it would zoom in on that point we're trying to find the slope or derivative of. Now, for the bottom equation, it's really the same thing. Okay, this is still a slope. This is just change in y divided by change in x. Or in other words, y2 minus y1 over x2 minus x1. Okay, imagine 2 points, x plus h, comma, f of x plus h. And this one right here, this would be x, and I should have wrote f of x. All right, so for the change in y, here are the y coordinates. You would just do f of x plus h minus f of x. That's what we have here in the numerator. In the denominator, you would just do x plus h minus x. Okay, if you did x plus h minus x, x minus x would cancel, and you are just left with h. So that's what we have in the denominator. So it's the same thing here. As h approaches 0, in other words, the difference between these 2 points gets smaller and smaller, okay? And you zoom in on that point like I showed you on the graph. If h approaches 0, this is a really small number. F of x plus h and f of x would be very close together, and you would zoom in on that point. So that's the idea here. All right, so which of the following is equal to g prime of 2 for g of x equals log of x? Now, first you want to look at your answers and see which form it's in. Okay, remember we said we were going to choose one of these two. We can see from all the answers here, it is divided by h. So clearly, we are using this one right here. Okay, so let's write this out. All right, so for these answers, for each of these answers, it's going to be the limit as h approaches 0 of f of x plus h minus f of x all over h. Okay, that's the formula. I got that directly from the notes. So I can see the answers are in this form. Now, how do we find x? Well, that's actually very easy. Right here, we're looking to find g prime of 2, okay? And this just means the slope at x equals 2. All right? So since we're looking to find the slope at x equals 2, all we have to do is sub that in. All right, so it's going to be f of 2 plus h minus f of 2, because we're subbing in 2 in place of x, all divided by h. Okay, and here is the function. I know it says g of x, but you can call it f of x. Same thing. It doesn't matter. Okay, it's just the letter they use. F of x equals log of x. So we can easily find f of 2 and f of 2 plus h. All right, let me make a little bit of room. All right, so it's easier than it looks. All right, let's do f of 2 first. That's a little easier. F of 2, here's our function for f of x. All right, f of x is going to equal the log of x. So f of 2 just means we sub in 2 in place of x. All right, so f of 2 is just going to be the log of 2. And f of 2 plus h just means we sub in 2 plus h in place of x. So that's going to be the log of 2 plus h. All right, so finishing this here, f of 2 plus h, that's the log of 2 plus h, minus f of 2. We said f of 2 is just a log of 2. And that whole thing is divided by h. All right, and we can clearly see that is answer A. All right, here's our original. Limit as x approaches e. Here's our function. Here's our answers. First, we want to find out which form this is in. We're not dividing by h. It's minus on the top, minus on the bottom. We're not dividing by h. So clearly, we are using this one right here, not this one. Okay, we're using this one here. So let's write this out. All right, so I wrote this out. All I did was get this from the notes. Okay, this is the main formula here. You can put the limit part out front. All right, limit as x approaches e. Anyhow, it's pretty easy to match this up with what we're given. Okay, we can clearly see the first term here, ln of x, f of x. So f of x equals ln of x. All right, so f of x equals ln of x. And let's see. We can see x minus t, x minus e. So we can clearly see that t equals e. And basically, since t equals e, okay, that's the point where we're trying to find the derivative. All right, so it's basically f prime of t, the number we're plugging in. This is a number. Remember, e is a number, is basically f prime of e. All right, so that's the number that's being plugged in. We said f of x equals ln of x, and f prime of t is f prime of e. Okay, you can see it. This is what we're approaching. Remember, in the formula, and I shouldn't have wrote e here. In the main formula from the notes, this is x approaches t. So e is the number where we're finding the slope. Okay, so that's f prime of e, and f of x equals ln of x. So that's it right there. All right, this is the number at which we're trying to find the slope. That number right there, or you can go by this right here. And the function itself is right there. So it's actually pretty easy. Answer A. All right, so here we have one. H approaches 0. It's divided by H. So that is clearly this one right here that's divided by H, where H approaches 0. All right, let's line it up with our equation. All right, so we have the limit as H approaches 0. And I am just writing from the notes here the main formula. It is f of x plus h minus f of x all over h. All right, pretty simple so far. So we can clearly see right here that f of x plus h is 2 to the power of 3 plus h. All right, so f of x plus h equals 2 to the power of 3 plus h. And we can see that f of x is 2 to the third. F of x equals 2 to the third. All right. So we basically have to figure out a function that would give us these results. And I believe it's pretty simple here. I believe based on these two that the main function f of x is 2 to the x. Okay, and then right here, this would be f of 3. All right, so if I got rid of the x here, this would just be f of 3. Okay, because you sub in 3 in place of x right there. And since x equals 3, this would also be a 3 right here. This right here would be a 3. All right. So basically, the main function is f of x equals 2x and x equals 3. So we're finding the slope. We're finding the slope at x equals 3. Okay. So in other words, f prime of 3. Now, in their answers, they use g prime, but same thing. All right. So if we scroll down, g prime of 0, no. G prime of 3, yes, but they got the main function wrong. G prime of 0, g prime of 3, where g of x equals 2 to the x. Okay, so that's it right there. Answer D. All right, which of the following is f prime of pi over 2 for this function? So you can clearly see that none of these have the h in the denominator. Okay, it is clearly in the form of this one right here. So let's line up everything and see what we can figure out. All right, so I wrote this out just from the notes. Okay, all I did was copy from the notes. Since we're doing f prime of pi over 2, clearly the value of x equals pi over 2. All right, and the main function here is f of x. So if we did f prime, let me see. All right, small mistake. This is not x, this is t. All right, the number at which we're finding the derivative or slope. All right, so this is t. So this is going to equal f of x minus f of t, but t is pi over 2. So it's going to be f of pi over 2 divided by x minus pi over 2. All right, and f of x is sine x. That was given. F of pi over 2 means you just plug in pi over 2 right there. So it's going to be the sine of pi over 2. And on the denominator, it's just x minus pi over 2. Final answer. All right. So this is not it here. This is not it here. Sine x minus sine pi over 2, we got it. X minus pi over 2, we got it. Okay, and x approaches t, which is pi over 2. Answer C. All right, so this number right here, or this variable, that's the point where you're finding the slope or the derivative. That's going to be your x coordinate. Yeah, so for this version here, the part in parentheses, that's your value for t. But for this version here, that's your value for x. Okay, that was my little mistake in the last problem. I used x for this when I really should have used t. So that's basically it. When it's in this form, this is t. And when it's in this form, this is x.